All right, this is part one of the lecture for refrigeration, all chemistry, and of course management. Now, this will be things you'll have to answer on your EPA exam. And so we want to make sure that you pay attention and get these terms down. It's kind of term heavy in the beginning. So in the beginning was page 224, and that's where we'll start. Your book says ozone is a gas. It's found in the stratosphere and the troposphere. So ozone is a gas. It is a form of oxygen made of 3 oxygen atoms instead of 2 oxygen that we breathe. Stratosphere ozone, which resides 7 to 30 miles above the Earth, is considered good ozone because it prevents harmful UVB rays from reaching the Earth. The troposphere ozone, however, is undesirable ozone because it is a pollutant. So ozone, we don't want here, we want up there. And it protects us. Okay? So the Earth's pretty sophisticated within its design. All right? Chemicals are reaching the Earth's atmosphere. Some of these chemicals are refrigerants. Refrigerants are stable if contained. Refrigerants are pollutant when released to the atmosphere. So your book first says ozone, which is 3, look what it says, 3 oxygen atoms, not 2 oxygen atoms like you breathe in. It's both in the stratosphere, 7 to 30 miles above the Earth, and the troposphere, ground level to 7 miles. Some of this can be on your EP exam. Remember, your EP exam, when I proctor the exam, you will all be given a different exam. And depending on what questions they ask, I don't know, but this has been on the exam. Stratospheric ozone is a good ozone, and it shields the Earth from excessive amounts of the sun's ultraviolet rays. The tropospheric ozone is considered a pollutant called smog. So here is the troposphere, and we don't want ozone here. We want ozone up here in the stratosphere. Within the stratosphere, the ozone protects us from harmful UV rays. Now, I don't care about your political arguments and what you think. I'm just telling you how the Earth works here and what's happening. Okay? Now look what it says next. Stratospheric ozone is formed when a reaction occurs with sunlight. The layer of ozone that shields the Earth from radiation, a protection essential for human health. It accounts for more than 90% of the Earth's ozone is in the stratosphere, protecting the Earth from radiation. Now, it's being depleted by man-made chemicals. What's going on here? The next paragraph says the troposphere, a lower atmosphere that extends upward from ground level to 7 miles, only holds about 10% of the ozone. So this part from the ground up 7 miles has about 10% of the world's ozone. Sunlight acts on chemicals in the troposphere, creating bad ozone. The ozone is bluish in color, which seen from the Earth makes you think the sky is beautiful. A popular term for tropospheric ozone is called smog. Tropospheric ozone, bad, is called smog, depending on where you're from. In Japan, if you remember in the 60s, we had that tragic incident where pollution created the smog monster, and Godzilla had to get involved. That's in your history books if you want to go back and read it. Some of your schools didn't want to talk about that. Now, once stratospheric ozone is formed, much of it is easily destroyed by UV rays. Now listen to this. It's very powerful and has a frequency of almost that of X-rays. What? The sun's radiation breaks down ozone into a regular oxygen molecule. Can you believe that? By design, ozone protects us from UV rays and radiation. And when the radiation hits the ozone, it breaks down and becomes oxygen. I don't know about you, but I'm about to sing and shout. That's some good stuff. Now look what it says next. At the same time, more ozone's produced from plants and bonding of oxygen with free atoms. The ozone is constantly being made and destroyed, and that's the way it's been for millions of years. The ozone is constantly being made and destroyed. Once in the stratosphere, UVs will separate chlorine from refrigerants. Okay, before we get to that, let's see what else we got here. The effects of ozone depletion, okay? Let's talk about that in about 2 seconds. Okay, so your book says this is what's happening. Refrigerants have chlorine in them. The ultraviolet radiation that breaks down ozone and turns it into oxygen also breaks down the chlorine from refrigerant. Refrigerants light it in the air and it gets up in the atmosphere. And when it does, the chlorine's broken down out of it. Now, who cares if the chlorine's up there? Well, let's see what your book says happens next. Once up there, it then goes on, the chlorine, to destroy ozone molecules. Now remember, the ozone's protecting us from UV rays and creating oxygen. One chlorine atom can destroy up to 100,000 ozone molecules. That will be on your EPA exam. And that will be on your test this Friday in this class. You have to know that. One chlorine atom can destroy 100,000 ozone molecules. One chlorine atom. The depleted ozone molecules in the stratosphere let more radiation in the earth now. Now this causes an increase in skin cancer, cataracts in humans and animals. It weakens human immune system and increases plant life. Okay? So your notes right here would say something like depletion ozone shield causes cancer. It also has an adverse effect on crops and plants. The molecules are made up of 3 oxygen atoms. Chlorine destroys ozone. One can destroy up to 100,000 molecules. That says 1,000,000. Does that say 1,000,000 on my forehead? I don't know. But it's 100,000, don't say 1,000,000. Now, ozone depletion potential. Your book then goes on to say, well, the United Nations Environmental Program got together and created the Montreal Program. This was under President Ronald Reagan. An index was created for ozone depletion called the ODP, ozone depletion potential. This has been used for regulatory purposes. Now, that's got a rating. Now, what does the rating say? The higher the ODP, the more damaging it is to the chemical to the ozone stratosphere. When stratosphere ozone intercepts ultraviolet lights, heat is generated. So something will get an ODP potential rating, and the higher it is, the more damaging it is. Okay, so ultraviolet lights are good. So we just talked about that. Okay, so in your next one, Now here in your book, they show you how it's going to, the UV rays break it off and causes problems here. Next lecture video, we're going to do global warming so we can understand that.